Alright, now we can just go for his new keyword. Now the syntax of making an object is something like class name. If suppose we have class 1, so it will be somewhere as 1o is equal to new 1. It will be 1o is equal to new. We can make an object like this. Now one thing we can just take care is that when we make this, when we use this new keyword, what happens actually? Actually, this complete process is what is happening behind is dynamic memory allocation. Dynamic memory allocation. That is, actually, if you just take care that using classes and objects, object is nothing but a data type, but it is a user defined data type. Means we can design its structure in our own way. So an object is a user defined data type. That is, we can design its structure in our own way. We can easily design its structure in our own way, right? So this specific object, if we just talk about this object, it is a user defined data type. Now this user defined data type will definitely, when the program is running, see, when program is running, we call it runtime. We call it runtime, right? So actually when the program will run, if you just see here in the same, I'll continue with the same employee example. So this is, suppose this is the runtime of the program. This is the runtime and the program, or timeline, this represents the runtime of the program. So when the program is running, an employee is created. Let's say here a specific employee is created. Employee Ram is created, right? And if suppose user needs to create another employee, he can create another employee. Employee Sham is created, or employee Harry is created. Employee Harry is created. Alright. Then if he wants to delete the memory of Ram, even that also he is capable of doing so. At this specific point of time, he wants to delete the memory of Ram. That is, he wants to delete a data, so he can delete that data. So runtime means a program. Suppose if our program is of HR management software, then this program will run the complete day. It will start when the office starts and it will end when the office will end. In the meanwhile, HR will perform various operations. These operations such as HR will create an employee, HR will delete an employee, or HR can even edit an employee and perform operations on employee also, and perform operations on employee. So basically when the person is doing all this, right? So what is happening here? The memory is being created and destroyed at runtime. Memory will be created and destroyed at runtime, right? So in C and C++, this facility was available through data structures or calloc-malloc function. This facility was available through the data structures or through calloc-malloc functions, right? So the complete memory management had to be done by user only. Complete memory management had to be done by user, right? But in Java, new keyword is used for creating a memory at runtime. It will create a memory at runtime, right? So what are the functions of new keyword? We can just discuss the functions of new keyword. Okay, so if we can just see here, in the functions of new keyword. Suppose we have class 1 here, we are having class 1, and basically when we will make an object of this program whose O1 is equal to new 1, we just made an object of this program. When this happens, a memory will be occupied here, right? A memory is occupied. Simply just imagine a memory, small memory is occupied, alright. Now this memory will have the same members as that in the class, right? So first and foremost thing what new keyword will do is it will allocate a memory in heap. Now heap is a new term to you. Heap is actually a part of RAM. Currently you can understand this. In future we'll discuss more about heap. So heap is a part of RAM. It is a part of RAM. Right. It will allocate memory inside the heap. Second thing what it will do is, right, see if you just try to understand this, O1, it will, this memory will be occupied at some memory address. Let's say its memory address is 152.0.0.2. Let's say this is its memory address, right? So this memory address will be allocated to O1. Actually this is happening. Means O1 will get reference of the memory. O1 is getting reference of the memory, and hence these data types are known as reference data types. I just referred them as simple data types and reference data type. That is the reason they are known as reference data types or complex data types. Because in second step what we can write is the reference of the memory will be given to the variable, right? So since this reference is given, hence they are also known as reference data types, right? We call them as reference data types. So what happens if we just try to print this? What happens if we try to print this O1? Okay, let's see what is going to happen. What I will do is system.out.println, let's say Shiva. Alright, when we just run it, and if you see there is something very absurd, first dot employee @E53108. Yes, it is related to memory address, but it is somewhat in organized format. We'll just discuss about it. But it is, yes, it is printing the memory address, right? So the object variable will contain the reference of the memory, right? And hence this is how the object is related to the memory. Object variable contains the reference of memory, hence the object variable is connected to that memory object. It is connected to that memory object. This is very much correct. Now basically, fine, it contains the reference of memory, the variable is connected to that specific reference of the memory will be given to that variable. This is all fine. One important point is that if we break this reference, the object is destroyed. Obviously, if we break this reference, the object is destroyed. The object is destroyed. How can we break the reference? We can easily break the reference using null. By assigning null to the object variable, we can break the reference by assigning null to the object. We can break its reference by assigning a null. Right. We can just assign a null to it, and this is going to break its reference completely. Correct. Now basically what we can just see here is, once the reference has been broken, right, we can just see here, if I just break the reference as Shiva is equal to null, and I go for Shiva.performance this time, this will return me a null pointer exception, because I am trying to perform a operation on a null variable. So it will return in a null pointer exception. If you just see, this is null pointer exception. This is an exception. Whenever we try to do any operation on a null variable, on a null object, we get null pointer exception. So if we try to do any operation on a null variable, we get null pointer exception. We will easily get as null pointer exception, right? Another important point is that when we are actually, or we can, I'll just explain you here. If I take one more variable here, 1, O2 is equal to O1. What is going to happen here? O2 will also point at the same memory reference. Here, O1 and O2 will point. So I can just demonstrate you here. If suppose I allot some details to Ram, but I do not allot the details to Shiva. What I will do is Shiva is equal to Ram, right? If I just made the object, what I just did is Shiva is equal to Ram, and I'll just declare it here. No need of creating new. Why? Because we are not creating a new memory here. We are using a already defined memory. We only need to use new when we are creating new memory. So here in this case, Shiva.address will be same and Ram.address will also be same. If you just see, we have a small error here. Okay. Right? Both of them are, since both of them are pointing to the same memory address, right? So we can also make objects where both objects will point to same memory. They are going to point to the same memory. Alright, this is very much clear. Now since they are pointing to the same memory, this is only possible if both the objects are of same class. If they are of different class, then this is not going to happen, right? So this is possible when the objects are of same class. This won't happen if objects belong to different classes. They belong to different classes, right? If they are belonging to some different classes, this is not the case. This is not going to happen at all, right?